Hello. Okay. So today we'll discuss the topic limits and continuity. Limits and continuity. Okay. So first we'll see what is meant by limits. What is meant by limits? Okay. So to define the limits, suppose we are having one function. Function is f of x. We have one function. I will say let y is equals to f of x be a function of x. Be a function of x. Okay. And we have one point at x is equals to a. Okay. At x is equals to a, or you can say if x is tending towards a, if x is approaches towards a, then what is the definition of limit? That is limit x tends to a, f of x is equals to L. Okay. So f of x is a function of x and this is x is tending towards a. This is called as limit point. Limit point. And here L is called as the what? The value of the limit. Value of the limit. Okay. Now this limit is having the two types or two parts, that is LHL and RHL, that is left hand limit and right hand limit. So left hand limit, how we write? Limit x tends to a minus f of x is equals to L. RHL is, that is right hand limit is limit x tends to a plus f of x is equals to L. This is what your right hand limit. Okay. Next now we'll see, I think okay, that is fundamental theorem on limits. Fundamental theorem on limits. Fundamental theorems on limits. Okay. If limit, I think if it is x tends to 0, f of x is equals to L, and limit x tends to 0, g of x is equals to m. Okay. Limit x tends to 0, f of x is equals to L, limit x g of x x tends to 0, g of x is equals to m, where this L and m are the two real numbers. Those are the real numbers. Okay. Then we have some rules here. Okay. See the first rule, it is limit x tends to 0, f of x plus g of x. Okay. It will be what? L plus m. It will be what? L plus m. Means what? We can separate the limit for sum of the two functions, that is limit x tends to 0 f of x plus limit x tends to 0 g of x. But f of x is what? L. G of x is what? M. Okay. Similarly, we can write limit x tends to 0. Okay. F of x minus g of x, it will be what? L minus m. Next, limit x tends to 0. Okay, this is f of x into g of x, so it is L into m. Similarly, limit x tends to 0, f of x divided by g of x, which is equals to L upon m. L upon m. Okay, so this is also called as algebra of limits. Algebra of limits. Okay. Next, okay, if limit x tends to 0, f of x is equals to plus infinity or minus infinity, then we have to express this limit in the form of what? Limit x tends to 0, 1 upon f of x, 1 upon f of x, which is equals to 0. Okay, if limit x tends to 0, f of x is equals to what? Plus infinity or minus infinity, then we can write limit x tends to 0, 1 upon f of x will be equals to 0, will be equals to 0. Okay. Next, now another property, limit, suppose if I take limit x tends to a log of f of x, limit x tends to a log of f of x, then it can be written as log of limit x tends to a f of x. Okay, this is another property. Next, one more I will take, that is, okay, see here, limit x tends to a f of x to the power g of x, then it can be written as limit x tends to a g of x to the whole power f of x, to the whole power f of x. Okay, sorry, I think I made the mistake in this condition. Sorry, here it is limit x tends to a f of x to the whole power limit x tends to a g of x, limit x tends to a g of x. Okay, this is another property. Okay, next, this properties you have to remember. Okay, next one is, see, this limits can also simplify with some methods like substitution method, factorization method, rationalization method, or direct substitution method. Okay, actually that substitution and direct substitution is meaning same. So direct substitution method, factorization method, and rationalization method. And one more method is what? If limit, if the limit is, it is in the form of x tends to infinity, if it is into x tends to infinity, then that limit or that function you have to convert in the form of what? 1 by that function. Suppose now see, if it is limit x tends to infinity x, limit x tends to infinity x, means here f of x is x, then if you have this type of problem in the limits, then first of all what you have to write? This limit you have to express in the form of what? 1 upon x, 1 upon x, and its value will be going to be 0, its value is going to be 0. I think I taught this result in the previous properties. Okay, so these are the 4 methods to simplify the limits, Okay, next, again another some more results are there. Okay, so just see what are those results here. Limit x tends to limit x tends to 0, sin x upon x is equals to 1, or limit x tends to 0, x upon sin x is equals to 1. Okay, So this also you learnt in the first year. Okay, next, limit x tends to 0, tan x upon x is equals to 1, or which is equals to limit x tends to 0, x upon tan x. Okay, again next, limit x tends to 0, sin inverse x upon x, which is equals to 1, or which is equals to limit x tends to 0, x upon sin inverse x. Similarly, we can write it for tan inverse x also. Limit x tends to 0, tan inverse x upon x, which is equals to 1, or limit x tends to 0, x upon tan inverse x, which is also equals to 1. Again, next result is okay. Next, see, limit x tends to a, sin of x minus a upon x minus a is equals to 1, or similarly, limit x tends to a, tan of x minus a upon x minus a is also equals to 1. Next, limit x tends to infinity, sin x upon x is equals to limit x tends to infinity, cos x upon x is equals to 0. Again, limit x tends to 0, e to the power x minus 1 upon x is also equals to 1. Let me write some more results here. Limit x tends to 0, a to the power x minus 1 upon x, a to the power x minus 1 upon x is equals to log a to the base e, Another one more, limit x tends to 0, e to the power lambda x minus 1 upon x is equals to lambda. After that, you should know what is L-Hospital rule. Okay, you should know in the limits, that is L-Hospital rule. What is meant by L-Hospital rule is, suppose now any function is given in the limit. For example, limit x tends to 0, sin x upon cos x. Suppose it is given. Okay, and you wanted to apply this L-Hospital rule. Otherwise, let me take this sin x upon x. Okay, now for such functions we use the L-Hospital rule. Why? Because see now, if I substitute the limit as x tends to 0 here, sin 0 is 0, and here x is also 0. So you are getting which form? 0 by 0 form. Actually, this 0 by 0 form is called as what? Indeterminate form, where the function is not defined, or where the limit is not defined. Okay, so to avoid this indeterminate form, we use the L-Hospital rule. So if I apply the L-Hospital rule, so that indeterminate form get eliminated, or it will get eliminated. Okay, So how to apply the L-Hospital rule? Limit is going to be same, no change in the limit. But what the L-Hospital rule says, okay, what the L-Hospital rule says, just a minute. Okay, so here L-Hospital rule, it means what? You have to differentiate the numerator and denominator separately. You have to differentiate the numerator and denominator separately. So what is the derivative of sin x? That is cos x divided by, what is the derivative of x? It is 1. Now if we substitute the limit here, x tends to 0, so cos 0 is 1 and 1 upon 1 is 1. Now I got the value of the limit or no? Okay, so therefore whenever you are getting the indeterminate form in the limits, so in that case we have to apply the L-Hospital rule. Okay, next. Okay, now this is what we have seen. This is about the limits concept. Now next let us see what is the continuity. What is the continuity? Okay, so somebody has asked the question in this is it is of which class? Okay, so its class is 11th and 12th together. I am teaching this or topic. Okay, in the 11th limits is there, continuity is there in the second year. So together I am taken this topic. Okay, next so we'll see what is meant by continuous function. What is meant by continuous function? See, suppose we have f of x, let f of x be a function, let f of x be a function, and it is continuous. It is continuous at x is equals to a. F of x be a function which is continuous at x is equals to a if three conditions must satisfy. First condition, f of a exists. Second condition, limit x tends to a, f of x exists. Okay, limit x tends to a, f of x exists. Now limit x tends to a, f of x exists means what? It may be LHL also should exist and RHL also get exist. Okay, and last third part is what? Third condition is what? So that exist limit and this f of a should be equal. Should be equal. And if they are equal, then we can say that the given function is continuous. The given function is continuous. Okay, this is mathematical definition for continuity. Suppose in some of the problems we have to go graphically also. Then how to check the graphically? That is about the continuous function. See now, suppose I am having one graph now. That is the graph of sin x function. Sin x function. See, this is the graph of sin x function. Okay, this is the graph of sin x function. So while drawing this curves here, so I have started from this point, so till this last point, see there is a continuous process. I have not lifted the hand while drawing or while taking that curve, so therefore this is the continuous function. Okay, this is the continuous function, means what? Sin x is a continuous function. Sin x is a continuous function. Okay, it means what? If any graph, if you are able to draw without lifting hand, there is no breakage in that, such functions are called as continuous functions. Again, for example, another one is polynomial function. See, x square or x cube, this is again continuous. Getting? Okay, or straight line y is equals to x is again a continuous function. Suppose we have this type of graph. I think this is the of e to the power x, I think e to the power x, or I think no, this is the graph of 1 by x, I think. Okay, see, this is one curve, this is one curve. So one curve first I have drawn here, I lifted the hand, I have drawn second curve. So it is what? Discontinuous function. Similarly, one more is there, another one more. This is done, no? Okay, suppose if I take this one now, this and this. Okay, so this is your signum function. Even see, this is also discontinuous only. Why? I have drawn one line here, I lifted the hand, I have drawn another line here. So which is again what? Breakage in the curve. So therefore it is discontinuous function. Okay, so mathematically you have to use this definition. Graphically means what? Graphically, if you are checking the function, that will be very easy. If without lifting the hand, if you are able to draw the graph, then that, or if you are able to draw the curve, then that function is called as continuous. And if you are break the curve, okay, means you have lifted the hand, then it is discontinuous function. Okay, then again in this you will find left continuous function, right continuous function, which is same as LHL and RHL, which is same as LHL and RHL. Okay, I think again which concept is left in this? Yeah, I think here we have seen the theory part about the limits and continuity. Okay, now let us go with the MCQs. Okay, now let us go with the MCQs of the topic limits and continuity. Okay, so that is the first question. First question is, okay, I hope it's visible, or let me have some adjustment. Okay, I think it's last adjustment. What is that function is if it's not visible? F of x is equals to x into sine of 1 by x and 0. Here if x is not equals to 0, x is equals to 0. Okay, f of x is equals to x into sine of 1 by x. If x is not equals to 0, f of x is equals to 0 if x is equals to 0. Then limit x tends to 0, f of x is equals to what? Is equals to what? Okay, so the options are 1, 0, minus 1 and none of the above, okay. Then see this problem, how you are going to simplify. Okay, how you are going to simplify this problem. Now see, f of 0 is what? 0. If I put x is equals to 0, f of 0 is 0. This is given in the function. Now you know what is the domain of the sine function. What is the domain of the sine function? It is closed interval of -1 to 1. Closed interval of -1 to 1. So therefore that sine function lies between -1 to +1. -1 to +1. Okay. Now let us multiply x on both the sides. So it is minus x less than equals to x into sine of 1 by x less than equals to x less than or equal to x. Now apply the limit. What is the limit? Limit x tends to 0 minus x less than equals to limit x tends to 0 x into sine of 1 by x less than equals to limit x tends to 0 x. Now as you know, if I put the limit is x tends to 0 here, so its value is 0 less than equals to, middle part keep as it is, x tends to 0 x into sine of 1 by x less than equals to, again this value is also 0. I think in the first year you have studied one theorem. Which theorem? Sandwich theorem. Sandwich theorem. Okay, what that theorem says, if this is 0, this is 0, then automatically the middle part value will be going to be 0. So therefore what? Limit x tends to 0 x into sine of 1 by x will be equals to 0. Will be equals to 0. So therefore option B is correct. Option B is correct. Okay. Next, second question. Okay, what is the second question here? If limit x tends to 2, which is x tends to 2, x to the power n minus 2 to the power n divided by x minus 2, which is equals to 80, which is equals to 80, where n is a positive integer, where n is a positive integer, then what is the value of n? What is the value of n? Options are 3, 5, 2 and none of the above. Okay, so here again what we have the function, it is one of the standard form, one of the standard form. I think I forgot to give you in the theoretical part. See, if you remember, if you learned this topic into the first year, this result, limit x tends to a, x to the power n minus a to the power n divided by x minus a, it can be written as n into a to the power n minus 1, n into a to the power n minus 1. So the same result is there here. Okay, only the thing is what, in the place of a we have the number is 2. So as per this result, what is the value of this? That is 2 into sorry n, no, n into that is 2 to the power n minus 1, which is equals to 80, which is equals to 80. Okay, okay. Next, n into 2 to the power n minus 1 is equals to 80. Then see here, you have to find out the value of n. You have to find out the value of n. Then how you are going to simplify this problem? It's very simple. What they have said here, where n is a positive integer, where n is a positive integer, it means what? It means what? You can substitute the values of n as positive integers. So positive integers means what? It will start from 0, 1, 2, 3 and so on. Okay. So if I put n is 0, 0 into anything it will be 0, which is not equals to 80. If I put 1, n is equals to 1. So 1 into 1 minus 1, 0, 2 to the power is 0 is 1. So 1 is not equals to 80. So like that, suppose let me put n is 4. So what will happen? This is 4 into 4 minus 1 is 3, 2 cube is 8. So I think it is 32, again which is not equal. Next you take n is equals to 5. It is 5 into 5 minus 1 4, I think 16. But 16 into 5, 80. So we got the answer is 80. We got the answer is 80. So therefore what? When I put n is equals to 5, I am getting this LHS is equals to RHS. So therefore option B is correct. The value of n is 5. The value of n is 5. Okay. So this result you have to remember. Okay, next function. If it's not visible, I'll write it. Limit x tends to 1. Limit x tends to 1. 2x minus 3 into root of x minus 1. Sorry. Root x minus 1 divided by 2x square plus x minus 3 is equals to, options are minus 1 by 10, plus 1 by 10, minus 1 by 8, and again none of the above. Okay, so see, limit x tends to 1, 2x minus 3 into root of x minus 1 divided by 2x square plus x minus 3. Now this problem, how you are going to simplify? See, there are 3 or 4 methods I told you: substitution method, factorization method, and which one? Rationalization method. Then how you are going to simplify with this problem? See, first of all, in the denominator we are having a quadratic equation. We are having quadratic equation. So let us factorize this first. Let us factorize this first. Okay. So what is the factorization of that? I'll write the factors directly. Later you check it. X minus 1 and 2x plus 3 are the factors of this quadratic equation. But I think it's not possible to cancel any numerator or denominator. Okay. Still, if you substitute x tends to 1 here, x tends to 1 here, again you will get your answer is 0 by 0 form. 0 by 0, that is indeterminate form. Okay. Means I can't substitute the limit at present now. I can't substitute the limit as present. Then we have to simplify for further. See what we can do then. Here I am having root x minus 1. Okay. Let me rationalize. I'll multiply by root x plus 1. I'll divide by root x plus 1. This I have done it. Now what will happen? See, limit x tends to 1. 2x minus 1 as it is. This is a minus b, a plus b. Then it will be what? A square minus b square. A square means what? Root x square is x minus 1 square is 1 divided by this x minus 1 as it is, 2x plus 3 as it is, and root x plus 1 as it is. X minus 1 get cancel. X minus 1 get cancel. Okay. Now check it. If I substitute the limit, what will happen? X tends to 1 here. So it will be, I think this is 2x minus 3. No, sorry. X tends to 1 here. 2 ones are 2 minus 3 is minus 1 divided by 2 ones are 2 plus 3 is 5 into 1 substitute here. Root of 1 is 1 plus 1 is 2. So answer is minus 1 by 10. Answer is minus 1 by 10. Okay. So option A is correct. Option A is correct. So this problem we have simplified with what? Factorization as well as rationalization method. Okay. So you just note down the solution. Okay, next question now. It's limit x tends to infinity, sin x upon x is equals to what? Options are 1, 0, does not exist, and none of the above. One result I have given in terms of this also, sin x upon x, which is equals to 1. But when it is possible, when limit is x is tending towards 0, when limit x is tending towards 0. If it is tending towards 0, then sin x upon x value is going to be 1. Okay, but here limit is x tends to infinity, then it's not going to be equals to 1. Okay, means option is not there only. So we have left 3, 0 does not exist and none of the above. Okay, so let us check which option is going to be correct from this. See, I think in the methods I told you, actually there are 3 or 4 methods. One is substitution method, factorization method, and rationalization method. Fourth, one more I told you, what, when you have the limit in the form of x tends to infinity, so that function we have to convert in terms of fraction. Suppose if function is x, then you have to write it in terms of what, 1 upon x, and its value is going to be 0. Okay, so by that case also, okay, which I taught you the result, what, whenever you have the what, your limit in the form of this, then it can be written as limit x tends to infinity 1 upon f of x, and its answer is going to be 0. Its answer is going to be 0. If you remember this property or this result, I think you can write the answer of this directly only. No need to simplify. Why? Because we know if you have the problem of this type, its answer is going to be 0. Its answer is going to be 0. So please remember this result. So here option B is correct. Option B is correct. Okay. Okay, next question number 5. So what is this question number 5 here? Limit x tends to 0. Limit x tends to 0. Root of 1 plus sin x minus root of 1 minus sin x divided by x is equals to, okay, limit x tends to 0, root of 1 plus sin x minus root of 1 minus sin x divided by x is equals to. Now at present, suppose if I put the limit is x tends to 0, what will happen? See here, sin 0 is 0, means you are left with 1. Here also sin 0 is 0, left with 1. 1 minus 1, you will get 0, divided by, if I substitute x is tending towards 0, again it is 0, means you will get indeterminate form. And whenever you get indeterminate form, you can use the methods or L-Hospital rule. Now I think it's here not possible to apply with the method. I may apply the L-Hospital rule here. L-Hospital rule. Okay. So by L-Hospital rule, limit x tends to 0. So what this L-Hospital rule says, you have to differentiate the numerator and denominator separately. Okay. So let us differentiate the numerator first. Okay, differentiate the numerator first. What will happen? What is the derivative of root of 1 plus sin x? 1 upon 2 root of 1 plus sin x into 1 derivative is 0, sin x derivative is cos x, minus again 1 upon 2 into root of 1 minus sin x into 1 derivative is 0, minus sign as it is, sin x derivative is cos x, and denominator is x. X derivative is 1. X derivative is 1. No need to write. Now here, I think you can take out 1 by 2 is common. Limit x tends to 0. What is left? See, cos x upon root of 1 plus sin x, minus into minus, plus cos x upon root of 1 minus sin x, root of 1 minus sin x. Then half into, if I substitute the limit, what will happen? Cos 0 is 1, sin 0 is 0, root of 1 is 1 plus cos 0 is 1 upon sin 0 is 0, sin 0 is 0, 1 minus 0 is 1. So it will be 1 by 2 into, so this is 1 plus 1 is 2, 2 get cancelled, answer is 1, answer is 1. So therefore option B is correct, option B is correct. Okay, note down the solution. Okay, next question number 6. So what is this function is, limit x tends to 0, 2 to the power x minus 1 divided by 1 plus x to the power half minus 1 is equals to what? Is equals to what? Options are log 2, log 4, log root 2 and none of the above. See, at present if I substitute the limit, what will happen? 2 to the power 0 is 1 and 1 minus 1 is 0. If I substitute 0 here, 1 plus 0 is 1 and 1 to the power anything is 1, again 1 minus 1 is 0, means we are getting here 0 by 0 form for this function, means it's not possible to simplify. And this can be simplified again by 4 methods: substitution, factorization, rationalization or by L-Hospital rule. Okay, substitution or rationalization also not possible, factorization is not possible only. Then we left with what? L-Hospital rule. Okay, so by L-Hospital rule you have to differentiate numerator and denominator separately. So what is the derivative of 2 to the power x? Okay, it is 2 to the power, I will write limit. So derivative of 2 to the power x is 2 to the power x log 2 minus 1 derivative 0 divided by, what is the derivative of 1 plus x to the power half? That is half into 1 plus x to the power half minus 1. How much half minus 1? I think it's minus half. It's minus half and minus 0. Now I think we can put the limit now, just check it. If I put the x tends to 0 here, 2 to the power 0 is 1, 1 into log 2 is log 2 divided by half into x tends to 0 is 0, 1 plus 0 is 1, 1 to the power anything is 1. So 1 by 2 shift to the numerator, so it will be 2 into log 2, so which is equals to, as per the using the property n log x can be written as log x to the power n, so log 2 to the power 2, so it will be log 2 square is 4, so answer is log 4, answer is log 4. So option B is correct again. Next we'll see limit x tends to 0, sin x minus x plus x cube upon 6 divided by x to the power 5, x to the power 5. This is the function. This is the question here. So you have to find out the value of this. Now at present, if I put the limit is x tends to 0, what will happen? This is 0, this is 0, this is 0, means 0. And if I put 0 here, it will be 0. So you are getting which form? That is 0 by 0 form, which is again indeterminate. Okay. So most probably whenever you are getting 0 by 0 form, try to apply the L-Hospital rule. Try to apply the L-Hospital rule. Okay. What will happen here then? Limit x tends to 0. Derivative of sin x is cos x minus x derivative is 1 plus this will be 3x square upon 6 divided by 5x to the power 4. If I substitute the limit now, cos 0 is 1, 1 minus 1 is 0, this will be 0, this will be 0. And still we can't put the limit. Again apply the same rule, that is LHR, L-Hospital rule. Okay, what will happen? Cos x derivative is minus sin x, this is 0, leave it, plus how much it will be? 2 3 is 6, x square upon 6 divided by 20 x cube. Again if I put the limit, sin 0 is 0, this is 0, this is 0, means still it's not possible. I think I'll cancel this 6. Let us apply again same rule, L-Hospital rule. Minus n as it is, sin x derivative is cos x plus x square derivative is 2x divided by how much? 60 x square. If I put it now, this is cos 0 is 1, this is 2 into 0 is 0, this is 0, but again 1 by 0 you are going to get infinity, which is not possible. So again you have to apply this L-Hospital rule. Minus n as it is, cos x derivative is minus sin x plus x derivative is 1, 1 into 2 is 2 divided by, I think this is 120x. See again if you put x tends to 0, here 120 into 0 is 0, but anything by 0 is again infinity, which is not possible. Again apply the same rule, minus into minus plus, sin x derivative is cos x, that is 0 divided by x derivative is 1. Okay, so 1 into 120 is 120. Now you can substitute the x tends to 0 here, cos 0 is 1 and upon this 120 as it is. So answer is 1 upon 120. So therefore option A is correct. Option A is correct here. Okay, now let us go with next question. Means in this problem, till you get the last final answer, we have applied the L-Hospital rule only. Okay. Now next question, limit x tends to 2 modulus of x minus 2 upon x minus 2 is equals to, options are 1, minus 1, does not exist and none of the above. See whenever it have the modulus sign or modulus function, see modulus function means what? Always it has the two values, minus plus, minus and plus, and whenever you get the modulus function always you have to apply the two types of limits, that is LHL and RHL. LHL and RHL, that is left hand limit and right hand limit. So let us take first LHL. So definition is what? Limit x tends to 2 minus, okay, function modulus of x minus 2 upon x minus 2, which is equals to, when your limit is left hand side, when your limit is left hand side, that is left hand limit LHL, then what is the modulus? Now see, whenever limit is left hand limit, then mod x value is what? Minus x. So like that, what is the value of modulus of x minus 2? Minus of x minus 2 upon x minus 2. Both will get cancelled. Answer is minus 1. Next, RHL, limit x tends to 2 plus modulus of x minus 2 upon x minus 2, which is equals to, when your limit is right hand limit, then modulus value is plus, so therefore modulus of x minus 2 is just plus of x minus 2 divided by x minus 2, both will get cancelled. Answer is 1. So if you observe LHL and RHL, LHL is minus 1, RHL is plus 1, which is not equal. And when you find LHL is not equals to RHL, in that case what we conclude? The limit does not exist. So therefore here option C is correct, that is the limit does not exist. Okay. Yes, next question here. Limit x tends to 0, e to the power alpha x minus e to the power beta x upon x, which is equals to what? Limit x tends to 0, e to the power alpha x minus e to the power beta x upon x, which is equals to what? Options are alpha plus beta, 1 upon alpha plus beta, alpha square minus beta square, and option D is alpha minus beta. Okay. Then how you are going to simplify this? See, this first try to convert in one of the standard result. Which one? Limit x tends to 0, e to the power x minus 1 upon x, that result. So for that, what we have to do it here? I have to add 1 and subtract 1 divided by x. Added 1, subtracted 1 in the numerator. Added and subtracted means what? Still the function is balanced. Still the function is balanced. Why? Plus 1 minus 1 if I get cancelled, again will get the main function. Okay. Now separate it. Limit x tends to 0. See this one part. This upon the denominator 1 plus that is e to the power alpha x plus 1 upon x minus limit x tends to 0, take minus in common here, e to the power beta x minus 1, minus n is common, no, plus 1 upon x. So I have separated these two terms with this denominator. So when I taught you the properties of limits, in that one result was there. Which one? Limit x tends to 0, e to the power lambda x minus 1, plus 1 upon x. Its answer is what? Lambda. Means whatever the x coefficient is there, that is the value of that limit. Then similarly in this above result, as per that property, what we can write? X coefficient is alpha, so this is alpha, minus x coefficient is beta, so it is beta. So the value is alpha minus beta. Option D is correct. See, it's important to remember the properties of limits also. Okay, fine. See, in this topic again around next 5 more MCQs are there, okay, but I will stop it here. You those 5 more MCQs, you practice it. If you find any difficulty, please let me know. I will send you the solution of that, okay. See, in the next class we are going to discuss about the continuity MCQs, and after that we are going to see with the differentiation, okay. Yes, we will stop it here. Thank you.